In this video, we're going to talk about intercepts, how to find the intercept of a rational function. If I given you a function fx equals to x minus 2, x plus 3 over x minus 1, and x plus 2, s minus 5, how do we find the x-intercept and y-intercept? So for y-intercept is when x equals to 0. So that means I want to evaluate the function when x equals to 0. I have 0 minus 2 times 0 plus 3 over 0 minus 1, 0 plus 2 times 0 minus 5. So I will have a negative 6 over 10, which simplify, I have negative 3/5. So our y-intercept is going to be 0, negative 3/5. So for x-intercept is when y equals to 0. That means I want the function equals to 0. So in this function, you set them equal to 0. Okay, that looks really complicated to solve, but it's not. If you think about this is a rational function, everything, if on the top the numerator equals to 0, the function is going to equal to 0. No matter how crazy the bottom is, it doesn't matter. As long as the top equals to 0, the whole fraction is going to equal to 0. So that means if the whole function equals to 0, our numerator equals to 0. So I have x equals to 2 or x equals to 3. So our x-intercept is going to be these two, 2, 0 and 3, 0. Okay, so right now we already learned intercepts and asymptotes. Now let's put this together and see how do we graph this function. So I want you to graph fx equals to 6 times x minus 1 over x plus 2 times x minus 3. So let's find the y-intercept and x-intercept first. So for y-intercept, I want to have x equals to 0, so I have 6 times 0 minus 1 over 0 plus 2 times 0 minus 3. So when we simplify it, we will have x equals to negative 6 over negative 6, which is 1. So our y-intercept equals to 0, 1. Now x-intercept. X-intercept is when the function equals to 0. When y equals to 0, I will have the top equals to 0, which means x is going to equal to 1. So x-intercept is 1, 0. Okay, next one is vertical asymptote. So for vertical asymptote, we want to set the numerator. We don't need to do anything about the numerator. We want to set the denominator, which is here, equals to 0. So I have x plus 2 times x minus 3 equals to 0. That is, our vertical asymptote is x equals to negative 2 and x equals to 3. We have a 2 asymptote, vertical asymptote. Next is horizontal asymptote. Horizontal asymptote we need to discuss case by case. So the degree of the numerator equals to 1, right? And then the degree of the denominator equals to 2. So that means the horizontal asymptote is going to be y equals to 0. All right, so right now we have everything. Now let's put this together. Let me label the y-intercept is here 1, 0, 1. X-intercept is 1, 0 in here. Oops, sorry. Here. Okay, and then the x-intercept is going to be in here. Oops. Okay, and then we also have a vertical asymptote at x equals to 2, negative 2, sorry, and then x equals to 3. Also a vertical asymptote at the x-axis. Okay, so here's the graph. So since when they approach in the asymptote, the graph is going to infinity, either going up or going down, right? So where does it look like? Well, since there's 2 intercepts, it's not hard to find that is going to be in here so that you can cross these 2 intercepts. If you do it the opposite way, like in this direction, there's no way you can touch these 2 intercepts, right? So it has to be go from the left to the right. Okay. So for other 2, so what does the graph look like? So that is related to the multiplicity of the asymptotes. So remember what's the multiplicity is how many repeated zeros occurs. So in this case, I'm going to use red. So this multiplicity, they both equals to 1. So that means their behavior is going to be similar. When it comes to 1, that means they're going to cross the asymptote. So at x equals to negative 2, the asymptote is on the upper left, right, of the asymptote. No, I'm sorry, upper right of the asymptote. So that means when it comes to cross, the other asymptote is going to look like this one. And then now look at number 3. When x equals to 3, that vertical asymptote multiplicity is equals to 1, right? So it's going to be cross. So now on the left side of the graph is in here, right? So that means on the right side of the asymptote, the graph is going to be a cross, like this one, on a different way. Okay, so when the multiplicity is an even number, what does the graph look like? So what does an even number look like? Let's say everything is the same except for one tiny change. I put a square at the asymptote s equals to 3. So if this multiplicity changed to 2, that means the graph is not going to be a cross or the opposite side. It's going to be on the same side. So that means at the asymptote x equals to 3, on the left side, the graph is in the bottom. That means on the right side of the asymptote, the graph also in the bottom, because the multiplicity is an even number. If it's an odd number, which is at the asymptote s equals to negative 1, the graph is going to be look like the opposite. If one is on the bottom, the other one is going to be on the top. Okay, I am going to show you another example about how to find asymptote. So now take a look. If I have a graph fx equals to 2 times x plus 2 over x minus 1. Again, find the y-intercept. Y-intercept is when x equals to 0. So I have 2 times 0 plus 2 over 0 minus 1. I have negative 4. So my y-intercept is 0, negative 4. And then x-intercept is going to be what? X-intercept is when the whole function equals to 0, which means the top equals to 0. So I have 2 times x plus 2 equals to 0. So x is going to equals to negative 2. So my x-intercept is going to be negative 2. And 0. Vertical asymptote. Vertical asymptote is when you set the denominator equals to 0. So that means my vertical asymptote is x equals to 1. So horizontal asymptote is something that we need to discuss case by case. So the degree of numerator is equal to 1 because that's the highest power, and the degree of denominator also equals to 1. Okay, so if these two degrees equal, the horizontal asymptote is equals to the ratio of the coefficient. So what is the coefficient? In this case, here is the coefficient of the numerator, and here is the coefficient of the numerator, which is 1, right? So that means the horizontal asymptote is going to be 2 over 1, which is 2. So now we can graph it now. We have a horizontal asymptote at x equals to 2, which, oh, I should use a dash line. Y equals to 2, sorry. And then a vertical asymptote happens at x equals to 1. Okay, we also have y-intercept negative 4 and x-intercept negative 2. So where do you think the graph started? The graph has to start it at the third quadrant, right? So the graph is going to look like this one, because when they approach into the asymptote, they're going to approach infinity. Okay, so now look at the graph. The multiplicity of the vertical asymptote. The vertical asymptote in here with the multiplicity of 1. So that means this is going to be a opposite side of the asymptote. So on the left side of the asymptote is going to be on the bottom. So that means on the right side of the asymptote, the graph is going to be on the top. It's the opposite because the multiplicity is an even number, is an odd number. If I change this to an even number, this is square. So the asymptote is going to be changed to what? The multiplicity becomes 2 now. So it's going to be on the same direction. It will be here. Okay, so that's it for today. Let me know if you have other questions.